Lesson 9, I will use the area model and division to show the equivalence of two fractions. If you'll think back to the objective of Lesson 8, it was I will use the area model and multiplication to show the equivalence of two fractions. Well, today we're going to still use an area model and we're still going to show the equivalence of two fractions, but we're going to use division today. In your math journals, I want you to write today's date. I also want you to write Lesson 9, equivalent fractions and division. We're going to be drawing two area models in our math journals today. Once you are ready, I want you to come back to the video and we'll get started. The first thing I want you to do in your math journal is I want you to draw this area model. I want you to notice that it's been divided into 1, 2, 3, 4, 5, 6 parts. And then you multiply that by 2, so it's actually divided into two parts. And I want you to shade part of it, okay? Once you get your area model drawn, I want you to write what fraction does the area model represent. Well, hopefully you said it represents 6/12 because we have 6 out of 12. But I bet if you look really closely at this area model, you can see another fraction besides 6/12. Hopefully you said that if you look at it really closely, you can see that half the area model is shaded, so the model also shows 1/2. This would be half of the model that's shaded. So we've got 6/12 and we also have 1/2. Now what I want you to do is I want you to take your pencil and I want you to circle each half. So normally we start out with halves and we draw lines to decompose it into 12s, but this time we're kind of taking the 12s and putting them all together to make halves. So we have this half is shaded and this half is not shaded. Here's how we're going to use division to show that these two fractions are equivalent. So instead of starting with the larger fraction, which would be 1/2, we're going to start with 6/12. It's not the larger fraction, but it's the larger unit, We're going to start with 6/12. 6/12. So you take your numerator and your denominator and you divide them both by 6, and that gives you 1/2. Now what we did last lesson was we kind of looked at this in the reverse. We said, okay, well we started with 1/2 and we decomposed it into 12s. So we had 1/2 is equal to 1/2, and we multiplied the top and the bottom by 6. And that gave us 6/12. So basically we're just doing the inverse, or we're doing the opposite. So in your math journal, I want to make sure that you went ahead and you circled the halves, and I want you to write this number sentence, the division one, because remember that is our learning target for today. We're using division to show equivalent fractions by going from the smaller units, which would be the 12s, to the larger units, which would be the halves. All right, we're going to do one more. So in your math journal, I want you to show me an area model that represents 2/8. And once you get that finished, I want you to come back to the video. All right, so now you have 2/8. Now when you take a look at that, can you group any smaller units together to make larger units? Yes, if you circled, just like I have, you could circle 2/8 together like this. And now if you look at the shaded part, instead of this being 2 out of 8, it is 1 out of 4. So we're going from 2/8 to 1/4. So we're going to go ahead and here's how we're using division. I want you to write this division sentence in your math journal. 2/8 is equal to 2 divided by 2 over 8 divided by 2, and that gives us 1/4. Okay? If this is still a little bit confusing to you right now, that's okay, don't panic. We're going to be doing lots more practice in our problem set today. All right, so let's go ahead and get out your problem set. Write your name at the top, and we're basically going to do the same thing on this problem set that we were doing in our journal. You're going to notice, first of all, it tells us right up front that each rectangle represents 1/2. That's why these area models are not labeled 1/2, because this sentence right here tells us that all of these are equal to 1/2, so we don't have to go through here and label each of these 1/2. Now what we're going to do is, instead of decomposing the shaded fractions, which means we're taking these larger units and we're breaking them down to smaller units, I want you to notice the verb that they use. Instead of decompose, they use the verb compose. So we're taking these smaller units and we're grouping them together to make larger units, just like we did in our math journal. And then we're expressing this in a number sentence using division. So you can see the first one has been done for us. They started out with 2 out of 4, and they grouped the 2's together to show that this could also represent 1/2. So using division, they divided the numerator and the denominator by 2, and they got 1/2. So if you look at this one, you can see that we're beginning with 3 out of 6. So let's go ahead and write 3/6 because that's our beginning fraction. So Could I compose any of these smaller parts into larger parts to make an equivalent fraction? Well, it's pretty obvious to me that half is shaded, so I'm going to go ahead and I'm going to circle. Here's 1, and here is 2. So 3/6 is equal to 1/2. So now I just have to show that with division. So I'm going to start with my numerator and my denominator. I'm going to erase this a little bit so that you can see my writing. All right, so let's go back up here and redo this. All right, so I'm going to take my numerator and my denominator, and I have to divide them both by the same number. Well, the only number that you can divide 3 by is 3 or 1. So I'm going to divide this by 3 because I took these 3 groups and I put them together. So now I have 1/2. All right, let's take a look at C. So what fraction do we begin with? We begin with 5/10. I've got 1, 2, 3, 4, 5 out of 10. So I've got 5/10. And I'm going to compose them. When I look at this, do you see a fraction besides 5/10? Well, I'm seeing 1/2 again. This half is shaded, and the same amount over here is not. So I have 5 out of 10 or 1 out of 2, which is 1/2 is shaded. So I've got 5/10, and I'm trying to get to 1/2. So to get from 5 to 1, and to get from 10 to 2, I have to divide the numerator by 5 and the denominator by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. All right, why don't you try to do D by yourself? If you get stuck, you can always press play on the video and do it with me. But go ahead and pause the video, look at what we've done so far, and do as much of this one as you can by yourself. Okay, so hopefully you started with the fraction that is represented first. I have 1, 2, 3, 4. Eighths. I have 4 out of 8. Out of 8. So I'm looking at this, and again, I'm seeing half is shaded. Every one of these has been 1/2, hasn't it? I bet it won't always be that easy, but for these first 4, it's been 1/2, hasn't it? So now I'm going to take my numerator, which is 4, and I'm going to take my denominator, which is 8, and I have to divide them both by the same number, and I'm trying to get to the fraction 1/2. So if I want to get from 4 to 1, I have to divide the numerator by 4 and the denominator by 4. So I have 4 divided by 4 equals 1, and 8 divided by 4 equals 2. So I have 4/8 is indeed equivalent to 1/2. All right, so now we're going to do the same thing, except you'll notice that these are not going to be quite so easy because they're not going to all be 1/2, but we're still doing the exact same thing. We're expressing the equivalent fractions in a number sentence using division. So I'm going to start with the original fraction. I've got 1, 2 out of 2, 4, 6. So my original fraction is 2 6s. So now I have to compose these fractions into larger units. So if I group 2 together like this, and I say, okay, those 2 go together, and these 2 go together, and these 2 go together, because remember, you have to have equal groups. So now, instead of this saying 2 out of 6, I can look at this as 1 out of 1, 2, 3. So I've got 2 6s is equal to 1/3. So I have to express this as a division sentence. So I've got 2, 6, and I have to divide the numerator and the denominator by the same number. So to get from 2 to 1, I have to divide by 2. To get from 6 to 3, I have to divide by 2. 2 divided by 2 equals 1. 6 divided by 2 equals 3. All right, same situation here. I have 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8. So I have 2/8. So now I'm going to compose them. Well, I'm going to go ahead and group these 2 together, and these 2 together, and these 2 together, and these 2 together. I want you to notice that every time that I group them, I always take my color and put them together. I would never want to take this part and then combine it with this part, because your shaded fraction has to be together. Your units have to be together. You can't have shaded and non-shaded in the same group. So now I went from 2 out of 8 to this group that's shaded. I have one group that's shaded out of 1, 2, 3, 4. So 2/8 is equal to 1 out of 4. So now I just have to express that using division. So I have 2 over 8, and I have to divide my numerator and my denominator by the same number. Well, to get from 2 to 1, I would have to divide by 2, because 2 divided by 2 equals 1. And if I divide the numerator by 2, I have to divide the denominator by 2. And 8 divided by 2 does equal 4. So 2/8 is equivalent to 1/4. So if you're starting to feel a little bit comfortable with this, why don't you pause the video and try to do C by yourself. If you're not quite ready for that, go ahead and do C with me, but I want you to prepare to do D all by yourself. All right, so let's take a look at C. I've got 2 out of 2, 4, 6, 8, 10. So I have 2/10. And now I'm going to compose. Again, I'm just going to put my 2 shaded together. So that becomes a group. This becomes a group. This becomes a group. So notice I'm just making groups of 2. So now, instead of having 2 out of 10, I have 1 out of 1, 2, 3, 4, 5. So 2/10 is equal to 1/5. So now I've got to divide my numerator and my denominator by the same number to go from 2/10 to 1/5. So what do you think I would divide 2 by to get to 1? Well, hopefully you said 2, because 2 divided by 2 equals 1, and 10 divided by 2 equals 5, because whatever I divide my numerator by, I must divide my denominator by. So now I want you to try to do D all by yourself. Remember, the worst thing that can happen is that you get it wrong. That's okay. You just come back, you erase it, you do it along with me. But I bet you'll get more of it right than you expect. So go ahead and pause the video, and when you're ready, come back and we'll work through it together. All right, so I'm starting with 2 out of 2, 4, 6, 8, 10, 12. So I have 2/12. Now I'm going to compose these in groups of 2 just like I have in the last 4. So I've got a group here, a group here, here, just circling my groups of 2. Notice that all of my groups have exactly 2 of them. So now instead of having 2 out of 12, I have 1 out of 6. Here's 1 out of 1, 2, 3, 4, 5, 6 total. So now I have to express this as a division sentence. So I've got 2/12, and I have to divide my numerator and my denominator by the same number. So in order to go from 2 to 1, I divide by 2. To go from 12 to 6, I divide by 2. All right, let's take a look at the next part. What happened to the size of the fractional units when you composed the fraction? So let's go back and look. So what happened to the size of the units? Look at these. They started out small, and when I composed them, what happened to them? They got larger, right? So that's what we're going to put. We're going to say the fractional units became larger when I composed the fraction. It's kind of like taking a pizza, and you've taken a pizza that's been cut into 4 pieces, and you take 2 pieces together and say, look, I made a half. So your pieces actually became bigger. If you could imagine that, you could uncut them. What happened to the total number of units in the whole when you composed them? Well, let's look at the total. I went from 6 to 3. I went from 8 to 4. I went from 10 to 5, and I went from 12 to 6. So what happened to the total number of units? The total number of units, what did it do? It decreased. When you divide, numbers get smaller. So when I decomposed the fraction, the total number of units decreased because I was putting smaller pieces together to have fewer pieces. So the pieces became larger, but the number of pieces became smaller. I did not change how much I had. All I did was just put smaller pieces together. All right, let's go back to full screen here. Oops, I didn't want to go that full screen. Let's try this again. How about single page? Okay. All right, let's keep going. In the first area model, show 2/6. In the second area model, show 3/9. Show how both fractions can be renamed as the same unit fraction. Okay, so let's just break this down and start with the first part. In the first one, we're going to show 2/6. So I'm going to go ahead and I'm going to divide it in half, just like this. And then I'm going to break it into thirds like this. So now I have 6 parts. And I have to shade 2 out of 6. So let's go ahead and get our highlighter here. 2 6s. All right, now in the second one, it says we are going to show 3/9. So I'm still going to go with 2 vertical lines, but I'm going to go with 3 horizontal lines so that I have a total of 9 altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to highlight 3 out of 9. So you'll notice really quickly that even though the pieces are smaller in the 9ths than they are in the 6s, the same amount is shaded. So actually these fractions are equivalent. So how can we show how both fractions can be named as the same unit fraction? All it says is show. It doesn't say that we have to use any kind of division sentence. So I'm thinking if we come over here and we circle groups of 2 like this, so I'm composing these into groups of 2. So now instead of having 2 out of 6, I'm going to have 1 out of 3. Well, what if I come over here and I circle these in groups of 3? So instead of having 3 out of 9, now I have 1 out of 3. Now it says express the equivalent fractions in a number sentence using division. So I've got 2 6s. Okay, I don't think I can go, well, yes I can. I could do like this. 2 6s is equal to 1/3. Let's show how it's equal to 1/3. All right, so I've got 2 divided by and 6 divided by. What am I going to divide 2 by to get to 1? I'm going to divide it by 2. So 2 divided by 2 equals 1. 6 divided by 2 equals 3. Okay, so 2 6s is equal to 1/3. Then I'm going to come over here and I'm going to do 3/9 the same way. So I've got 3/9 is equal to 1/3. So let's decompose this using division. All right, so what would I divide 3 by to get to 1? I would divide 3 by 3, which equals 1, and 9 divided by 3 equals 3. So I've got 3 divided by 3 equals 1, and 9/3, 9 divided by 3 equals 3. So I've got 2 6s is equal to 1/3. I'm going to write that over here. I've got 2 6s is equal to 1/3, and I've got 3/9 is equal to 1/3. So 2 6s is equal to 1/3, which is also equal to 3/9. All 3 of these fractions are equivalent. All right, in the first area model, show 2/8. In the second area model, show 3/12. Show how both fractions can be composed or renamed as the same unit fraction. So we're pretty much going to do the exact same thing here, except we have different fractions. So I have to show 2 out of 8. So the first thing I'm going to do is I'm going to make a horizontal line, and then I'm going to divide this into 4s going this way, because I know that that's going to give me 8 parts. That line's a little bit crooked, so I'm going to try to go back and fix that. All right, so let's come back and straighten that up. Okay. Now these aren't exactly equal. They're close enough, but they're not perfect. I'm going to straighten this one up just a little bit. All right, so now I'm going to shade 2 out of 8. Okay, so I've got 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8. So I have 2 8s. Now over here I have to show 3/12. Okay, so to make this 12s, I'm going to go with 2 horizontal lines so that I divide this into 3 parts. But I'm still going to go with 3 vertical lines just like I did on the 8ths. So when I finish here, I should have 4 groups of 3, which is equal to 12. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I have to shade 3 out of 12. Let me come here and shade 3/12. So can you see the 2 equivalent fractions? Good. So you can see that now we just have to compose them so that they can show that they are the same unit fraction. So if I take these 2 and I compose them or put them together, and then I make 3 more groups of 2, you can see that I have 1 out of 1, 2, 3, 4. So it's 1/4. I come over here. This time I'm going to put groups of 3. This is a group of 3, group of 3, group of 3, group of 3. So I still have 1 out of 1, 2, 3, 4. So I have 2 equivalent fractions here. Now I'm going to express the equivalent fractions in a number sentence using division. So I'm going to start with my 2/8, and I'm trying to show that 2/8 is equal to 1/4. See if you can't fill out this middle all by yourself. Pause the video and see if you can't figure out what goes here. Okay, hopefully you said, well, 2/8, I have to divide my numerator and my denominator by the same number. And to get from 2 to 1, I have to divide by 2. To get from 8 to 4, I divide by 2. All right, now let's see if we can't do this one. If you feel like you can do this one all by yourself, give it a try. You're going to start with 3/12, and you're trying to write a division sentence to show that 3/12 is indeed equal to 1/4. See if you can't finish that. All right, hopefully you said 3/12, and you can divide your numerator and your denominator by 3, because 3 divided by 3 is 1, and 12 divided by 3 is 1/4. So I've got 2/8 is equal to 1/4, which is equal to 3/12. So all 3 of these fractions are equivalent. Okay, so that is all of our problem set for today. So I want to review just a little bit. We were basically doing the exact opposite of what we did in the lesson 8. In lesson 8, we started with the larger units. We would start with 1/4, and we would draw lines to decompose it into smaller parts. And we used multiplication because we were going from smaller numbers to larger numbers. We were going from fewer parts to more parts. Well, now we're doing the opposite. We're starting with fewer parts and we're putting them together. So to show that, we have to use division because we're going from more parts to less parts, but they are still equivalent. Just remember that when you get ready to do your exit slip or your practice, if you need to go back and look at your problem set, that would be a great place to start.